In this video, I'm going to hack around on Mesa and try to figure out how I can get a traveling salesman problem set up. I'm thinking about this in two ways. One is constructing a graph, because I believe they have like a network grid or something. Like the one I got from Boilerplate is this this grid here. Let's see. Let's just take a quick look. Multi-grid. So I think this has like integer positions. But I know the space. So if you're not familiar with VS Code, the way I did that, by the way, is like I want to know what other spaces there are. So I right click here and go to definition. And this is opening up the space file, which is in the Mesa source code. So now I can kind of scroll around through here. Now it might be faster to look at their documentation, but I kind of like to go this way. Okay, so we have grid. I don't know what a property layer is. Okay, single grid, multi-grid. That's what I have, right? Multi-grid. Whoops. Multi-grid. Okay, a rectangular grid where each cell can contain more than one agent, right? Yeah, single grid, I think each cell can only contain a single agent. Okay, so this is hexagonal. Hex single grid, hex multi-grid. Okay, I don't know what's different about that. A continuous space, okay, cool. Network grid, here we go. Network grid where each node contains 0 or more agents. So it looks like I pass in G, which is a network X graph instance. Perfect. Okay, let's install network X. Let's make sure. Oh, I already have it. Great. That must have been a requirement. Make sure you guys can see this. Okay. So now I need a graph that represents my traveling salesman problem. Network X traveling salesman. Okay. Let's see what we got. Find the shortest path in G. Okay. So this assumes I already have the graph. But what I really want right now is just an example graph that works for this sort of problem. Okay, so I'm in algorithms here, but what I really want are some predefined graphs. I mean, perhaps I can just get like a random graph with, or I'm sorry, a complete graph with random weights. Or I could just assign points randomly to a 2D space and then construct a graph from that. I think that's the way to go. A random geometric graph. What's this? In a unit cube. Places n nodes uniformly at random in the unit cube. Okay. 2 nodes are joined by an edge if the distance between the nodes is at most radius. So if I do 2 dimensions and have a radius that's larger than the graph, or I'm sorry, the unit square, then perhaps that will do what I want. Let's see what happens. All right, let me just see if it will generate the positions for me. So this is 20 nodes, the radius of 0.1. Okay. Okay. Okay, so it does have positions. It's definitely not a complete graph. Okay, so let's see what happens when I make this equal to just some large number. Because if it's a unit cube, the distance should be no greater than 1 ever. Okay, so this should basically be a complete graph. So let's see, what are the length of edges? $190. Okay. So I think I have all of the edges. It's just that they are not reversed. Because the maximum number of edges is 20 times 19. Because you have each node connected to all the other nodes except for itself. But then you divide that by 2 and you have 190. And that's how many edges we have. Okay, so I think this will work, at least to get started. So we want where did it go? Nope. Something like this. So self dot grid equals. All right, I don't think that's the right arguments. It needs to be G. So we will create a graph. Whoops. I'll parameterize this later. I should be able to make that anything larger than 1. Yes, yes. Okay. Place agent on node ID. Okay. So what were my node IDs? Okay, they're just integers. So I should be able to make an integer. Here, let's just make this num cities. So, okay. Yes. Okay. City. Okay, so if I pick a number between 0 and 20 or whatever, the number of cities, that should be a node ID. Then I can place this agent on that node ID. Okay. Let's save that. I'd rather open up a new terminal in case I need to keep playing with that. Okay, I don't know how this plotting is going to work, but let's see what happens. What was it? Solara. I forget now. Run. Oh, with, okay. I need to update my parameters. Num cities is 20. Draw network grid. Oh, hey, it's kind of working. I see draw network X being called. Size and color. Okay. I don't know what it wants me to return here, so I will just return nothing. See what happens. Hey, look at that. I have a graph. I have no idea if those positions are correct. How can I tell it that the position of this node, but wait, this is giving me an agent, not, let's see, get neighborhood. Does this have any notion of like weights on the edges or anything? Because if not, that could be an issue for me. Because ultimately, I'm going to have an edge weight between two cities that's proportional to something like 1 over distance or whatever. And I want my positions that I've attached to the nodes. So if you recall, in network X, we have this POS attribute on our nodes that have the X and Y coordinates in 2D space of where the city is. And I don't think that this is reflected here. Okay, get neighborhood. So how does the visualizations interact? Okay, I'm going to break it just so I can see what code is being called here. Okay, where are we at here? Network X PyLab. So it's being passed the position and keyword args. My guess is that okay. React on core. Components, space, matplotlib, draw network X grid. Ooh, that's looking promising. All right, let's go here. Okay, so it takes my graph. It's using a spring layout. But that doesn't help me because I already have the positions. It would be nice if this was optional so that I could pass in POS, but if POS was none, then do this. Let's see. Is this a way to access it? Is it nodes? I always forget how to. Let's see. How do I get data out of a network X graph? Okay. I'm trying to figure out how to interact with the data attached to this graph. Because I assume that this is a dictionary. Yeah, POS, dictionary optional, with nodes as keys and positions as values. Okay, but what do the values look like? Is it just a tuple? So we need to figure out what it's supposed to look like. Spring layout. Okay, I think this gives you the positions. A dictionary of positions keyed by node. Okay, I don't know. Let's look at it. Okay, so it's just an iterable of length 2. So maybe I could do something like key value, and then I want the POS key for key value in g.nodes.data.items, and I meant for that to be a map, not a list. Okay, let's see. Maybe we can wrap this in a dictionary. Okay, that seems to work. So before I forget and lose track of this, let's just go ahead and get these positions here. So this is on our model. Okay, now I could conceivably change this source code to allow me to pass in position, but where is this being passed in? In space matplotlib. Line 18. Oh, Solara component. Okay, so the model is being passed in. Okay, so I could do it right here. So get adder model pos none. So if self.pos or model.pos exists, it should return it. Otherwise, it should return none. And I'm going to pass that into this method and then change this, or function rather, and then change this with a default of none, so it should be backwards compatible. If pos is none, then do that. Otherwise, do that. Okay. Let's see what happens. Oh, that's because I broke it on purpose, right? Now, let's see if this looks, it looks different now. So it seems like it is plotting on the positions. I'm going to see if this works. No. Oops, there's too many of these running. Okay, yeah, clearly different seeds are giving me different graphs here. Whereas before, I don't think that would happen. I mean, I would get different graphs, but I think the spring layout would make it look about the same. So here, let's just comment that out for a second. So then it should default to what it used to do. And yeah, see how it's like very symmetric? Yeah, see the plotting is like always the same. But if I include the position, get rid of that. Cool. Now the drawback, of course, is that now my version of Mesa is different than everyone else's because I've changed the source code. Maybe I could make that a pull request, but if I remember correctly, they have like a ton of pull requests that are just kind of sitting out there. So I'm not that optimistic that mine would get through. Okay. So what have we accomplished? Well, with our traveling salesman problem, we've assigned positions to our nodes, and our space representation takes that into account. I don't know that will affect anything. The visual representation won't necessarily change the algorithm when we start doing searches. So maybe we just chalk it up to just having not the best visualization, or we create like a custom visualization or something and not use this. I don't know. We'll see. But at least we have some path. Now the next thing we might want to do is create some variation of the edge visualization that represents the distance here. So, for example, maybe the thickness of the edge is proportional to 1 over the distance, something like that. Or if it's really far away, we make it like opaque. I don't know. And it just occurred to me, maybe instead of hacking on this visualization, we should just create our own totally separate one, and then we have full control over it. So let me see what that would be like, because I think in their documentation they have like a custom, building your own visualization component. Okay, so let's do this. I don't know why this is here. I don't think we're using that. I don't think we're using that. We're about to be using this. Okay. Oh, this is on stable. We want this on latest. Okay, let's go back. Building your own visualization. Solara. Okay, and then you add it as a measure here, whatever this function ends up being. So we need network X again. Okay, so G equals model.g, right? Oh, we don't save G. We should. Okay, so there's our graph. And then, let's see. I'm trying to remember. Draw network X grid. Oh, that did nothing. We can remove that. All right, graph X. Agent portrayal. I don't know what this is, so we're going to ignore it. We're going to call this make graph. All right, let's see what happens. Ah, yes. Okay, so that's way easier. We shouldn't change the source code. Let's just get rid of all this. Okay, so yeah, now we have the original up there. We're back to normal source code land, and here's our custom graph where we've stored this position. Cool. Okay, so now that we have access to network X, we can simply modify it by using their normal sort of draw commands. So I know they have like a ton of node list, edge list, line widths. Line width of edges, float or array of floats. So if we wanted to change the width of the edge to be proportional to something like 1 over distance. Yeah, let's try this. Set edge width based on between nodes. Well, let's see what happens here. I don't think we have a weight. Oh, width equals weights. Let's see. Where was it? There's something about edge widths, right? I swore I saw it before. Okay, draw network X. Node color, node shape, alpha. Line width of symbol border. I think that's around the nodes, right? Oh, width. Line width of edges. Float or array of floats. Okay, so I don't need to... I can do that here, right? Now, the only question is whether there's weight here. Okay. NX lin ouch, is that a thing? Yeah, I don't know what this is, so I'm just going to calculate it manually. Okay. That seems right. Okay. See what happens. Yeah, it looks like these are very thick. Edge color equals gray. I didn't know that I wanted to do that. Okay, cool. Maybe not helping the visualization very much, but it's good that we can manipulate this how we want it to be. Great. So we have a traveling salesman problem set up. We have cities that have positions. We can change the seed to get different city layouts. And we understand the distance between them. We've attributed that to the graph. We should probably do that in the model. Let's go ahead and do that. So let's add a new method here called create graph. And we'll do all the graph stuff. Okay. I'm definitely not married to this API of a class, but it'll get us started. We want self.g here. All right. I'm debating. Yeah. Because I think I'll okay, we can delete that. Okay, cool. So why is this changing all of a sudden? Before, that wasn't changing. Oh well. Oh, unless it's using the weight to change that layout implicitly. Let's test that real quick by commenting out this. Oh, interesting. So when it draws this, it must look for a key called weight. When calculating that, what was it, the spring layout? Weight equals weight. Ah, okay. Well, that's good to know. I wonder what happens if I uncomment this. Does it somehow use my weight? No. Okay. Cool. So we have this traveling salesman problem set up. Now we'll be able to start putting some ants on here and laying some pheromones and implementing some algorithms.